Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a square prism having edge of the base equal to 40 millimeter and axis length is provided to us as 65 millimeter. Now this square prism is resting on one of its rectangular faces onto the horizontal plane such that its axis happens to be parallel to the horizontal plane and the axis is further inclined at an angle of 30 degree with respect to the vertical plane. So here we can see we have got a rectangular prism which is resting onto its rectangular face onto the ground. So the front face of this rectangular prism we have marked as 1, 2, 3, 4, whereas the rear face of this rectangular prism has been marked as A, B, C and D point over here. So now as the square prism is resting on one of its rectangular faces onto the ground, so the axis of this prism happens to be parallel to the horizontal plane. And to begin with, we will assume that the axis of the prism happens to be perpendicular to the vertical plane. Now, in this first iteration, we are going to use the principle of the projections of the solids and we are going to tilt this prism axis at an angle of 30 degree with respect to the vertical plane. Then whatever front view orthographic projections we are going to obtain, in those projections now we have to use this condition, that is the solid has been cut by an auxiliary inclined plane passing through the midpoint of the axis in the front view projections such that this AIP happens to be inclined with respect to the horizontal plane at an angle of 40 degree over here. So with this information, we are required to draw the front view projections, the sectional top view projections and the true shape of the cut section of this inclined square prism over here. Let us proceed with the construction of the orthographic projections of the square prism when the prism happens to be resting onto one of its rectangular faces onto the ground. Axis of the prism happens to be parallel to the horizontal plane and perpendicular to the vertical plane. So here once the axis of this prism happens to be perpendicular to the vertical plane, then the two faces, that is 1, 2, 3, 4 and A, B, C, D. So both of the square faces, they are going to coincide with each other in the front view projection. So if we are going to look at the solid from the front and the axis happens to be perpendicular to the vertical plane, so we are going to obtain the overlapping front face and the rear face projections corresponding to the square prism. Now we are going to obtain square projections onto the vertical plane in the front view projections over here, and the edge of the square face happens to be 40 millimeter. So now as we have discussed, the two faces, they will be overlapping with each other. So we are going to get points 1 dash and A dash coinciding with each other. Points 2 dash and B dash, they will be coinciding with each other at the base. So this is the rectangular face onto which the square prism happens to be resting onto the ground. Now corresponding to the top face, points 4 and D, that is 4 dash and D dash, will be appearing at the top face into the front view projections over here. Similarly, the points 3 dash and C dash corresponding to the points 3 and C, they will also be overlapping with each other corresponding to the top face of the square prism over here. Now having obtained the front view projections onto the vertical plane, now let us proceed with the construction of the orthographic top view projections of this prism over here. So we know that once we draw projections through the points 4 dash, D dash, 1 dash and A dash, So the first projector line we can draw over here. Similarly, corresponding to the points 3 dash, C dash, 2 dash and B dash, another projection line we can draw over here. Now we know that the length of the axis of the square prism happens to be 65 millimeter. That is the distance between the points 4 and D, 1 and A, 2 and B, 3 and C happens to be 65 millimeter. Now we can mark this distance of 65 millimeter over here. So this way, the top view rectangular projections of the square prism we can obtain onto the horizontal plane below the XY reference line. And now we can check when we are going to look at the square prism from the top. So this is the rectangular projection we have been able to obtain. So this edge, it is equal to 40 millimeter. This edge happens to be 65 millimeter. So here we can observe in the front face points 4 and 1. They will be overlapping with each other in the front view projection. Similarly, points 3 and 2 will be overlapping corresponding to the front face projections of the square prism. Corresponding to the rear face, points D and A and C and B, they will be overlapping with each other. So this way, we have been able to obtain the front view and the top view projections of the square prism. When the square prism happens to be resting onto one of its rectangular faces onto the ground, axis of the prism, it is parallel to the horizontal plane and perpendicular to the vertical plane. Now in the first iteration, we have been provided with the information that this prism has to be rotated in such a way with respect to the vertical plane such that the axis of this prism will be inclined at an angle of 30 degrees with respect to the vertical plane. So now we have to mark the axis of the prism. So we can have the midpoint of these edges, that is A, B and CD over here. Similarly, we will have the midpoint of the front face edges, that is 1, 2 and 3, 4. So we can mark the axis over here. Similarly, in the front view also, we'll have the midpoint of the edges 1 and 4 and 3 and 2. So this way, these 2 points, they will also be located over here. So here we are able to obtain the midpoint O dash and O1 dash over here. So O dash point corresponds to the axis point corresponding to the rear face of the solid, whereas O1 dash point, that is O1 point, refers to the axis point corresponding to the front face of the solid. So here in the front view projections, both O1 and O points, they will be overlapping with each other, whereas in the top view projections corresponding to the rear face, point O will be located over here. Corresponding to the front face, point O1 will be located over here. So this way we have been able to mark the axis points corresponding to the front view and the top view projections over here. Now we know that this solid has to be reoriented with respect to vertical plane such that its axis should be parallel to HP and inclined to vertical plane at an angle of 30 degree. So these top view projections we have to reorient with respect to vertical plane in such a way that at an orientation angle of 30 degree with respect to the vertical plane, we have been able to obtain the transformed or rotated view of the plan projection view in such a way that the axis points O and O1, they will be located alongside this orientation line, which happens to be inclined with respect to the vertical plane at an angle of 30 degree. So now using rectilinear distance method transfer, we have been able to transfer these plan projection points into the new orientation. So we can check. First of all, we will be marking these axis points O and O1. So the same distance as available with us in the previous plan projection view, we are required to draw over here. Next, from point O, we will draw a perpendicular projector. Mark the distances between O and CB, O and DA. So O and CB distance will be transferred over here. O and DA distance will be transferred over here. Similarly, from point O1, distance of O1 from the points 3 and 2, distance of O1 from the points 4 and 1. So they will be evaluated from this plan projection view and corresponding perpendicular projector from O1 will be drawn, and these two distances O1 and 3, 2, O1 and 4, 1. So these 2 points, they will be marked over here. So this way, using the principle of rectilinear distances, we have been able to transfer the plan projection view corresponding to the square prism when prism happened to be having its axis perpendicular to the vertical plane into the new orientation when the axis is parallel to the horizontal plane and inclined to vertical plane at an angle of 30 degree. Now, having obtained the plan projections corresponding to this inclined square prism, now we are required to obtain the front view projections over here. So from all of these 8 points, we have drawn vertical projector lines into the elevation projection view, and the horizontal projector lines we have drawn through all the points of previous elevation projection view. Now the corresponding points of intersection of the vertical projectors through the plan projection view and the horizontal projectors through the elevation projection view we are going to obtain. So here we can see this is the vertical projector through the point A over here. This is the horizontal projector through the point A dash. So the intersection of these two projectors provides us with the location of the point A dash in the elevation projection view. Similarly, this is point B of the plan projection view. This is point B dash of the previous elevation projection view. The intersection of vertical projector through B and horizontal projector through B dash, it has provided us with the location of the point B dash. Similarly, point C dash has been obtained by virtue of intersection of the vertical projector drawn through the point C and horizontal projector drawn through the point C dash over here. Similarly, point D dash has been obtained corresponding to the point of intersection of the vertical projector drawn through the point D and horizontal projector drawn through the point D dash over here. So this way, all the 4 points of the rear face of the inclined square prism, they have been obtained. Now corresponding to the front face, now here we have got point 1. So from point 1 we have drawn a vertical projector line. From point 1 dash we have drawn a horizontal projector line. So the intersection of these two projector lines has provided us with the location of the point 1 dash over here. Similarly, here we have drawn a vertical projector line through point 2. This is the horizontal projector line through point 2 dash. So the intersection of these two projector lines provides us with the location of the point 2 dash in the elevation projection view. Next we have got vertical projector through point 3 intersecting with horizontal projector through point 3 dash, yielding us with the point 3 dash in the elevation projection view. And here we have got point 4. So from point 4 we have drawn a vertical projector line. From point 4 dash we have drawn a horizontal projector line. The intersection of these two projectors provides us with the location of the point 4 dash in the elevation projector view. Similarly, now we need to evaluate the axis point. So here we have drawn the vertical projector through the point O, horizontal projector through the point O dash. So this provides us with the location of the point O dash in the elevation projection view. And finally, the last point is O1. So corresponding to this O1 axis point lying in the front face, we have drawn a vertical projector line through O1. Wherever it intersects with the horizontal projector line drawn through the point O1 dash, we obtain the point O1 dash in the elevation projection view. So this way, all the 10 points of the elevation projection view corresponding to this inclined square prism, they have been obtained. Now one thing we need to know over here, that this edge CB, you can check this edge CB. So as we have rotated this prism in this way, so this edge CB happens to lie farthest away from the observer or nearest to the plane when the observer is going to look at this inclined prism from this side. So this vertical edge CB, which is represented as C dash B dash in the front view projections, so this has to be drawn dotted over here. Now in the front view projections, we can see this is point O dash, that is axis point corresponding to the rear face of the solid. This is axis point O1 dash, which is lying in the front face of the solid. Now, the distance between these 2 points, now we have known through the construction over here. Now we are going to measure this distance between the 2 axis points which happen to lie on the rear face and the front face of the solid respectively. Now, once we measure this length, that is O dash and O1 dash, now we know that in the second iteration, we have been provided with this information that this inclined solid is cut by an auxiliary inclined plane passing through the center of the axis, and this AIP is inclined at an angle of 40 degree with respect to the horizontal plane. So now the midpoint of the axis, now we need to evaluate in the front view projections over here. So this point we have labeled as point P dash over here. So point P dash, it is the midpoint of the axis length which is appearing to us in the front view projections over here. So once we locate this point P dash, now a cutting plane passing through the point P dash, that is the midpoint of the axis, and inclined at an angle of 40 degree with respect to the horizontal plane, cuts this inclined square prism over there. So we can check, once this prism is cut by this auxiliary inclined plane, cutting plane at an angle of 40 degree, now this portion of the solid has been removed over here. So we are no longer having this portion available with us. This portion has been discarded or removed. Now we are left with, this is the remaining solid which is left behind. So once we know that this is the remaining solid which is left behind after the sectioning of this inclined square prism over here, now we are required to evaluate the points of intersection which this cutting plane will be providing us onto this inclined square prism over there. Now we can check the first points which are available with us. They are lying onto the base. So when we are going to look at the solid from the front, so we observe that this solid has been cut by this AIP inclined at an angle of 40 degree in such a way that this edge A dash B dash has been cut at a point P1 dash over here. So please check, A dash B dash edge of the square prism corresponding to the rear face of the solid has been cut at the point P1 dash. Now the second point is the point of intersection of the edge of the base A dash and 1 dash over here. You can check, this is A dash, this is 1 dash. This edge of the base has also been cut or sectioned by this cutting plane. So the name of this point happens to be P2 dash. So the 2 points corresponding to the base we have been able to obtain. Now we can locate these points into the top view projection. Once we draw projection from P1 dash, and we have already discussed P1 dash point happens to lie onto this edge AB over here. This is the base edge AB over here which measures 40 millimeter. So now onto this base edge top view projection, wherever this vertical projector will be intersecting, we obtain the point P1 over here. Now the second point of intersection is P2 dash. And now P2 dash, it is the point of intersection of the cutting plane with the longer base edge which is A dash and 1 dash. This is A dash and this is 1 dash. So this edge A1 has been intersected by the cutting plane at the point number P2 over here. So as we move in the clockwise direction, different points we are going to locate. So the first point was on this edge, that is AB. Second point lies on the edge A1. Now the third point of intersection of this cutting plane will be with this vertical edge, that is 4 dash 1 dash. It is this edge 4 1 over here. So if we look at this edge, so we find that one point will be located over here because onto this vertical edge only one point of intersection or POI we are able to obtain. Onto this edge, wherever the cutting plane passes through this particular edge, so point P3 dash has been marked in the elevation projection view. So now if we look at this point P3 dash from the top and we draw a projector in the downward direction. So this point P3 dash, it will be observed at the same location where points 4 and 1 they were located. Why? Points 4, 1 and P3 they will be overlapping because all 3 points they are falling on the one vertical edge which happens to be perpendicular to the horizontal plane over here. So if P3 point lies over here, somewhere here, so if we look at it from the top, if we look at this edge from the top, so points 4, 1 and P3 they will be coinciding with each other in the top view projections over here. So as we are moving along in this direction, now next point which is encountered is these 2 points, that is this point over here. This point means here again the cutting plane is going to intersect or cut 2 horizontal edges corresponding to the top face over here. The first horizontal edge which is cut by the cutting plane, it will lie on this side, that is between 3 and 4. So between 3 and 4, it is this top face shorter edge over here which has been intersected by the cutting plane. So the name of this point we are going to label as P4 over here. So name of this point will be P4 and the corresponding point on the top face will be P4 dash. And the next point which will be available with us by virtue of intersection of the cutting plane with the top face over here. This edge happens to be now 3 dash and C dash. You can check, it is this edge 3C. So this edge has also been cut on the top face, that is the longer edge of the top face has also been intersected by this auxiliary inclined plane. So name of this point is P5 dash. This point which is available on longer horizontal edge which is available at the top face of the solid. It is 3 dash and C dash. This is 3 dash. This point happens to be C dash. So 3 dash C dash longer edge which is available on the top face of the square pyramid has also been intersected at point P5 dash. Now once we bring a vertical projector through P5 dash, now this is the longer edge 3C available over here. So the next point which will be available over here will be point P5. So this is 5th point which is available corresponding to the intersection of the cutting plane with the top face of the solid. Now the last point as we move along, it will be encountered on this vertical edge, that is CB. Where is this edge? It is this vertical edge CB. And into front view projections we can check C dash B dash has been intersected by this cutting plane at this point. So this point of intersection we have labeled as P6 dash and it is lying on the vertical edge. So if we are going to look at this vertical edge from the top, so wherever P6 may be lying over here, it is lying somewhere here. So points C, B and P6, they will be overlapping with each other in the top view projection. So they have coincided with each other. Now, having obtained all the 6 points of intersection in the front view projections and all these 6 points we have also obtained in the top view projections over here. So now we know that this portion of the solid has been cut and thrown away. This is the sectioned portion of the solid which is available with us. So now the sectioning we have carried out and now we can check it out over here that this portion corresponds to the apparent shape of the cut section of the solid which happens to be inclined with respect to horizontal plane at an angle of 40 degree. So since this cut section happens to be inclined with respect to the horizontal plane, so the top view projections corresponding to these 6 points P1, P2, P3, P4, P5 and P6. So this will represent apparent shape projections obtained in the sectional top view over here. So now one more thing here we have to observe that this portion of the solid has been removed. So we are not able to see anything over here corresponding to this removed portion of the solid. But this is the portion of the solid which is the uncut portion of the solid. up till now we have just obtained the front view and the top view projections corresponding to these 6 points of intersection which are corresponding to this section solid. But this portion of the solid, it has not been cut by the cutting plane. So this portion of the solid also needs to be drawn because it has not been removed by the cutting plane. So this portion, since it has not been sectioned, so we have not carried out the sectioning of this portion of the solid over here. Now, having obtained the front view projections and the top view projections of different points of intersections of the cutting plane with the existing solid, now we have to obtain the true shape of this sectioned solid over here. So how this true shape of the sectioned solid we can obtain? We have to draw an auxiliary inclined plane x1, y1 parallel to this cut section or parallel to this cutting plane over here. So we had drawn the cutting plane inclined at an angle of 40 degree with respect to horizontal plane. So parallel to this cutting plane or the cut section, which involves these 6 points of intersection over here, a new auxiliary inclined plane x1, y1 we have drawn. Now, through these 6 points which are available over here, 4 projector lines we have drawn perpendicular to this auxiliary inclined plane. Now, whatever auxiliary plan projections we are going to obtain over here corresponding to the 6 points of intersection whose edge view was available with us in the front view projection, whose apparent shape projections they were available with us in the top view projections. So here in the auxiliary plan projections corresponding to these 6 points of intersection, we will be able to obtain the true shape of the cut section. Why the true shape will be available over here into the plan projection view obtained on this AIP? Because this AIP x1, y1 happens to be parallel to this cut section over here. So let us proceed to evaluate all the 6 points of intersections onto this auxiliary inclined plane x1, y1. Now first point available with us is P1. So now we are going to measure distance of point P1 in the top view projection from the XY reference line. So once we measure distance of point P1 from XY reference line, now from the point P1 dash, so this is the projector line we have drawn. So onto this projector line, ahead of the plane x1, y1, the same distance of point P1 from the XY reference line we have marked it out over here. So this way the location of the point P1 in the auxiliary plan projection view has been obtained. Now the next point happens to be P2. Now again we are going to measure the distance of XY reference line and point P2 over here. And once we measure the distance of the point P2 from the XY reference line, now we have drawn this projector line from the point P2 dash, because P1 dash and P2 dash, they are overlapping with each other in the front view projections. So onto the same projector line which is drawn through the point P2 dash, the same distance of the point P2 from the XY reference line, we are going to mark it out over here. So now the position of the point P2 in the plan projection view has been obtained. Now the third point of intersection available with us in the top view projections, it is P3. Now we are going to measure the distance of the point P3 from the XY reference line. Now onto the projector which is drawn through the point P3 dash onto this projector line. The same distance of point P3 from the XY reference line will be transferred as distance from the auxiliary inclined plane x1, y1 over here, right? So this was the distance of the point P3 from XY reference line. So same distance from x1, y1 we are going to mark corresponding to the point P3 over here. Next point happens to be point P4. So we'll measure the distance of the point P4 from the XY reference line. Now this is the projector line corresponding to the point P4 dash of the elevation. So onto this projector line, the same distance of the point P4 will be marked from the previous plan projection view into the new auxiliary plan projection view over here. So the point P4 has been appropriately located in the new auxiliary plan projection view. Next point happens to be P5. So now we will be measuring distance of the point P5 from the XY reference line. Now let us see where does this point lie in the elevation view. This point happens to be P5 dash. So from this point P5 dash, we have drawn this projection line, and onto this projection line which is emerging from the point P5 dash, same distance of point P5 we are going to mark ahead of the auxiliary inclined plane X1 and Y1. So we can again check P5 point lies at this distance from the XY reference line. So onto this projector line we have marked the same distance as location of the point P5 into the auxiliary plan projection view over here. And the last point is P6. So once we measure the distance between point P6 and the XY reference line, now this is the front view projection P6 dash over here. So onto this projector line which is emerging from P6 dash, now the distance of point P6 and the XY reference line we are going to project over here. So this distance of P6 from X1 Y1, it is equal to distance of 0.6 from the plane XY over here. So this way all the 6 points of intersection corresponding to the cut section, they have been obtained onto the auxiliary plan projection view. And once we join all of these points, now we have been able to obtain the true shape projections of this cut section, which is appearing onto the inclined square prism, in which the axis of the prism happens to be inclined with respect to vertical plane at an angle of 30 degree, and this axis we can check, it is parallel to the horizontal plane. The axis of the prism, it is parallel to the horizontal plane and inclined at an angle of 30 degree with respect to the vertical plane. So this way we have discussed the construction of sectional front view projections, sectional top view projections, and the true shape projections corresponding to this cut section over here, when the square prism was resting on one of its rectangular faces onto the ground and the axis was inclined at an angle of 30 degree with respect to the vertical plane, and the cutting plane, that is auxiliary inclined plane, it was passing through the center of the axis. This is the center of the axis, and the AIP was inclined at an angle of 40 degree with respect to the horizontal plane. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the sectional front view, top view projections of the solid, and evaluation of true shape projections of the cut section when the solid happens to be inclined with respect to the vertical plane and it is cut by an AIP which is inclined with respect to horizontal plane at an angle of 40 degree. So we will be continuing with further discussion regarding few more illustrative cases of section of the solids in the coming lectures. So thank you very much. Thanks a lot.